On drawing number 18, there are 12 problems, missing line problems. You're only going to be required at this point to do 1 through 6. But if we look at these problems, we see that they all have a common issue in that one view is missing lines. And we have some tools that we can use to attack these problems. One is the orthographic projection technique that we use to make multi-view drawings. We know that if we have the 3 views, that everything in each view should correspond to the adjacent view. So looking at this, we would know right away, I'm going to look at number 9 here, we would know right away that since there are no lines in the top view, that probably is where we need to add some. And so if we put our 45-degree miter line, let's just bring some sketchy lines over here. Here's my 45-degree miter line, and I can bring these lines across and up. Let's see, like this. Bring these lines here, and I see that I have many lines that give me some possibilities in the top view, but it's tough to know which ones would actually work, and that means which ones would actually fit the front view and the side view as well as the top view. Well, another way to approach this, in addition to using the orthographic projection technique, is to use what we've been looking at with isometric constructions and sketches. And so if I were to come over here and make an isometric sketch, I'm going to make a box, my construction box, keeping it approximately the same dimensions as what we have here, and this is basically a cube shape. Then I can put my front view on the front of the box. If I look at this, I have this angle and this line here horizontally, which it's hard to tell exactly what would be on the front plane, but I'm going to assume, because I'm seeing visible lines up here, that this is all on the front plane, because there's the same elevation here, and that tells me that this might be on this front plane and this is cut out behind it. So I'm going to just make a quick sketch and put that view on the front of my construction box. And then I'm going to put the right side view, what I think is on the right side plane, over here. Now if I were to look at the top and these possibilities with the lines that I have, I could take possibly this shape, and that would give me just a starting point, just to see if that might be a solution. And so that would be something like this, if I were to bring this out. And then we say, well, how do we make these connections? Well, we have parallel surfaces, and we look here and we see that we're going to have a triangle shape. And to get a triangle shape, that means that this sloping surface would probably come down like this. It would connect to a vertical surface here. That would give me my triangle right here. And then this is an inside corner, which is generally going to require a perpendicular line to these other 2 sides. And so this might be a solution. So if I look at this, darken in some of this, I can say, well, that might be a workable solution for this drawing. Now if it is, then I would also have a line here where the slanted surface meets this horizontal surface, and that would put a line right here. So let's take a look at this. If we call this surface A, B, and C, then that would be A, B, and C, and that works from the front view. If we look at it from the side view, we could have D, E, and F, and that also works from the right side view. And from the top, we have this shape and we have this line right here, so it would also work from the top. So this is one possible solution. Now what you should know is that it may not be the only solution, because this is all variable. And actually, if we look at this drawing, there is another possibility. If I were to change this slightly by making this an angle, then let's look at what that might do to our isometric. Again, I'm just going to make an isometric cube. Something like that, just quick, doesn't have to be perfect. Put my angle here and come over this way, just as I did before. Only now the top is going to change slightly, and it's going to come out like this, and then it's going to angle this way. Now if we did that, then here's what would result. We would still have our slanted surface here. We still have our triangular piece here, but this would connect this way. But when we look at that from the front, we would still have surface A, B, and C, although C is now on an angle, but that would not matter from this view. If we look at it from the right side, we would still have D and E, excuse me, but C, because it's on an angle, would now be visible here. So this would change to C, and it would still satisfy what we see in the top view if we changed and put this angled line in here. So by sketching these and looking at them as best we can in 3 dimensions on a flat piece of paper, we can work through some of these and try to come up with different ways that they might be solved. So keep an open mind and work through these using orthographic projection techniques and isometric sketching techniques.